Welcome and thank you for attending this 300 level session Don't Cry Over Spilled Memory. Let me tell a story. A few days ago, a friend called me. Hey bro, I'm in trouble, could you help me? Yes, sure, as long as it's not to fix a printer again, I can help you. Do you remember that migration on my data warehouse environment that we talked about? My boss is requesting an ROI report. I need to explain to him what benefit we got from the money we spent on the migration. How can I do this? That's easy. SQL Server 2017 has many new features that will give your environment an immediate improvement as long as you change the compatibility level from 2016 to 2017 on each of your database. One of these new features is the memory grant feedback. This is a great feature to help us against the spills. Let's talk a bit more about the spills. When a query first arrives on the server, it's compiled, the plan is stored, and it's executed. All the following executions will use the plan stored in the cache. The amount of memory this query needs is defined during the compilation, and all other executions are using this value from the plan, a fixed amount. Then, our well-known query monsters arrive. Parameter sniffing. When we get different parameters on the query, this changes the amount of data the query returns and will change the amount of memory the query needs. Bad statistics. When we get bad statistics when the query compiles, the amount of data will be completely different and the memory need for the query will be completely different. Lots and lots of insert and updates. This will completely change the amount of data the query returns, and this changes the memory need for the query. What will happen to our query plan after all these monsters? This is our query plan using 87 and 200 kilobytes of memory and with a spill. This means SQL Server is using TempDB to process this execution, because the amount of configurable memory in the plan was not enough. This will be way slower than a regular execution. We can fix this using memory grant feedback. This feature will identify the spill and fix the amount of memory in the query plan inside the cache. All the following executions will not have the spill anymore and the memory will be fixed. I barely completed this explanation and I could see the disappointment face of my friend. What's the problem? Oh, you are using a colon store index. I don't have colon store index on my environment. I can't use batch mode features yet. I could be a bad person and say to you to wait until SQL Server 2019, when memory grant feedback will be available for whole mode and not only for batch mode. But there is another solution for this. Let me get my bag of magic tricks and do a demonstration for you. First, let's execute this query, which has a sort spill problem. While the query executes, I'll create an extended event session. I believe you already know about extended event, and I will start this session. I'm capturing the memory grant updated by feedback event. We will be capturing all the queries fixed by this new feature, so we can build an ROI report to your boss showing all the queries improved by the migration. Let's check the result of the query Here we see the query with a sort spill. The plan has a sort spill, but this query is using whole mode. It can't use memory grant feedback because it's using row mode. Let's solve this problem. I will create a very strange non-clustered column store index over a key that's not being used on this query and with a very strange filter on the index. Let's create the index. Let's execute the query one more time. And let's understand what I did with that non-clustered column store index. The batch mode requires a column store index. The column store index needs to be on the table, but doesn't need to be used by the query. This creates a solution for us. We can create a clustered column store index, filter it. We can build a filter that will result in no rows. So we'll be creating a dummy column store index to avoid any change on our environment. And this column store index will be enough to enable batch mode on our environment. Let's check the result of the query. Here we see the execution plan. The query still has a sort spill, but now this query is executing in batch mode. It can use memory grant feedback. In fact, this query is already using memory grant feedback because after the spill happens, the execution plan is fixed. Let's check. We can open our extended event session to check, and we will see the XML event already captured. But the best solution to check this is making a query over our extended event session. We are retrieving the data from the extended event session, and we can see the memory were fixed. We see the original amount of memory, the new amount of memory. The fixed happens only one time, and the query fixed. So when I execute this query one more time, the spill will not be here anymore. That's the time when I pretend to tell a joke and you pretend to laugh. And that's it. The execution plan and no spill. No spill. It's gone and the problem is solved. And we have the report to your boss showing the queries improved by the migration. But executing this query again over the extended event session, we have a surprise. There is one more line here. The first line increased the amount of memory, but the second execution decreased the amount of memory. So the memory grant feedback feature not only increased the amount of memory, but also decreases the amount of memory if it identifies the query doesn't need all that memory to be executed. I could see my friend's impressed face about this demonstration. A few days later, he called me saying his boss gave him a raise and he would never again need to call me to fix his printer. Thank you very much.